For lecture 13, we'll first take a look at this other thing that we'll be using for the second arc. Okay, so loops. We've actually kind of seen loops before when we were doing comprehensions. So remember, a comprehension is something like this, x4, x in range 10. Whenever we have a comprehension like this, we're looping over each of the elements of this sequence over here. So that's why we have this. So when we say loop, it's basically repeating something several times. So for example, we have this over here. So if you think about this, this is kind of like a comprehension, but just rearranged. So now we have this part. I'll directly copy this part. For x in range 10, I add a colon after. Then here, this is where I have this x over here. So if I just put x here, this will give me the same values, 0 through 9. So this is kind of similar to whatever is actually happening here. So this is what we call the for loop. So this is actually different from this comprehension here. This thing is an imperative construct. So what a for loop does is very similar. For each element in the sequence, it does something, whatever goes inside here. So for example, if I wanted to print out something, so print high. For each element in this range, it prints out high. So we see here, we have 10 instances of high over here. So that's what a for loop allows us to do. Okay, so again, note that these are different from comprehensions, although the syntax is a bit similar. The main difference is comprehensions are expressions. So in one of the previous, I think, lab lectures, we went over ternary statements. So for example, if I have x is 1 if true, else 0. If I print out x, since this evaluates to true, it will get the value 1. If I do false here instead, 1 if false, else 0, x will now be 0 instead. So this is what we call an expression. It evaluates to some value. This is different from, I did something like, if true, x is 1, else x is 0. Although this is kind of the same thing as this line over here, these are different. This is an expression, while this is a series of statements. So that's the same difference as comprehensions and loops. Yung comprehension a while ago, this is an expression, while this is a statement. Okay, so loops are usually used for side effects. So printing is one common side effect. So if we want to print something several times, we usually use a for loop for that. Last time, how I would do printing was something like tuple, then print x for x in range 10. This would print this out, but it would also give me some garbage value at the end. For loops, you can now do, I'll copy this entire thing again, colon, then print x. And what this will do is give me the same thing, 0 to 9, but without generating this garbage value here. So you usually use a for loop if you have some block of code that has a side effect. Okay? So for loops are usually used in imperative programming. So this arc, the second arc of CS11. And actually, we've actually already seen a loop before when we did recursion. So if you remember this, when we wanted to do something several times, So define f of n. If n is 0, we don't need to do anything anymore. Otherwise, you do that thing first before calling n minus 1. So if I wanted to call f of 5, this would print out high 5 times. This technically counts as a loop. So this actually isn't declarative. If you notice here, there's a print inside this function. So this is actually an impure function. So we've actually already used an impure function before. This is, well, depending on you, this is not really the nicest way to actually make a loop compared to for I in range 5, print high. This is a lot more concise compared to having to do it recursively. But yeah, the point is, these two do the same thing. So when it comes to actually making a for loop, since they have side effects, it might be difficult to grasp, especially if your for loop gets more complicated. So for example, if I have this over here, I have a single variable, so that represents my sum. Then I'm going to loop over 314. I'm going to add each of those elements to the sum, then get the current sum, or well, print k. If I do this, you'll see here that it prints out all of these. But since I have an additional side effect over here, this sum is also going to change. So actually, how do we actually know how this sum variable changes? Well, to do that, we can do what we call unrolling. So this for loop over here can actually be represented as this diagram. So you start over here, you're going to initialize the variable to the first item, then you're going to loop something over and over. So if anything goes on over here, you're going to do that thing. Then you're going to continue iterating over the sequence. If there are more items, you update the variable, then do the loop body again, then so on and so forth. So this is a diagram of how you can visualize a for loop. So the idea is to visualize what's actually happening. We can unroll that loop. So from this, we can turn that to this linear thing. So the first thing you do is still setting the variable. Then you're just going to turn this series of operations. You're going to do that again and again. So perform the loop body, then set variable to the next item, then so on and so forth, until you're done with the actual sequence. So in Python, you can also unroll a for loop. So from this over here, you can unroll that to something like this. So you're going to start with your variable as well as the sequence. This k will start as the first element of that sequence. Then this is just your loop body over here. So loop body, then what you do is this part will just continue. After the first iteration, you go to the second iteration. After the second iteration, you go to the third iteration. Then at the end, this is where you actually print out the sum. So you unrolled this loop over here to this bunch of lines over here. Okay, so because of this, since we now have a sequence of operations that we do here, it's easier to see what actually happens when we run all of the statements on the right side over here. We just go from top to bottom. And that will give us this series of printouts over here. So the basic idea is, if you have a loop, or if you don't know how to write a loop yet, if you're not sure of how to write a loop yet, try writing out the sequence of statements first, then roll that back up into a loop. So here, yung sum is acting as a accumulator. It accumulates yung values inside the sequence. And at each point in the loop, it has some partial result. So it's kind of similar to a cumulative recursion. It's accumulating these values over here. So for product, it's something very similar. So same sequence, the update I just make is different. And since this is a product, if I set this to 0 instead, all of this would still remain 0. So that's why I start with 1 instead. I multiply 3, then 1, then 4. So that's for a product. So let's have some more examples. So if I wanted to implement the factorial function using a for loop. So let's start with this. What I want is, I want to do 1 times 2 times 3 times so on until n. So it's essentially something like, I have an initial value, I have a result that initially has a value of 1. Then what I keep doing is I have some sequence, which is basically the numbers 1 to 9, or 1 to n, 1 to n. So what I do first is I multiply it by the first element. So let's say k is the first element of the sequence. I multiply the result by that first element. That's one iteration of my loop. After that, I'm going to update my variable k to the second element. Then I'm going to multiply it to the result again. Then I'm going to keep doing this until I finish iterating over the entire sequence. So this would be the unrolled version of my for loop. What if I want to use a actual for loop instead? Well, for that, what I would do is we start with a result of 1. Since this is what I want to iterate over, I would be iterating over for something in range 1, 2, and plus 1. Then what goes inside is the part that repeats. So if k is assigned to each element of the sequence, that's the k over here. What I'll do inside the for loop is just this part that repeats. Result is result times k. Result is result times k. Then in the end, I just return the result. And there, that's how we implement factorial using a for loop. If I have factorial of 10 now, that gives me 10 factorial, 5 gives me 5 factorial, then so on. So if I do it like this, I will get the same results as if I implemented this recursively. Okay, so this is essentially what we did. Alright, so you've seen from the previous examples, we have lines like this. If we have something where we have a variable and we're reassigning it using that same variable, so here I'm using sum to update sum. There's a slightly shorter way to write this, and that's like this. You just use plus equals instead of this thing over here. So instead of something like x is 1, and I do x is x plus 1, I can do something like x plus equals 1 instead. Plus equals will be the same thing as this line over here. And this also works for other operations. So x times equals 3. So x is now 6. X divide equal 6. X is now 1. And so on. So any operator then equals. This will replace x with whatever the new value should be. So this is what we call augmented assignment. So for the previous examples, we can slightly clean them up like this. We can use the augmented assignment instead of explicitly writing out the variable twice. Okay. So again, you can also do this for most of the other operators. Okay. So let's go through a few more examples first. If I have a sequence and I want to print out all of the even numbers. Okay. So define print all evens. Then I have a sequence. If I wanted to print out all of the even numbers here, normally what I would do is, let's say we have the first element of the sequence. We only want to print this out if it's even. And we know that it's even if yung remainder, when divided by 2, is equal to 0. So if it's equal to 0, we're going to print out that element. And we're going to move on to the next element. X is sequence 1. If x is even, we print it out. And so on. So this is how our entire process would look like. If we were to use a for loop for this, what we can do is print all evens. So this is the variable that's updating. So we have for x in, yung sequence is just whatever the input sequence is. So for x in sequence, this is where I put the part that repeats. So here, the part that repeats is these two lines here. If x is even, print x. So if I do that, print all evens, let's just give it a range, 1 to 20. This will print out all of the even numbers from 1 to 20. So there, that's how we do it with a for loop. This is the part that repeats. This is how we're iterating over the sequence. Okay? So again, start with the unrolled version. This is the unrolled version. Then roll that back up into a for loop. Okay, so another thing, if I wanted to collect them into a list instead. Okay, so define all events of a sequence. I need to collect them into a list, so I need to start with an empty list. So x is sequence 0. If it's even, I append that to the end of the list. And I do the same thing for the other ones. L.append x, then so on. So if I want to roll this back into a for loop, what I would do is all even sequence. L starts as an empty sequence. Then since x is the value that iterates over the sequence, I do for x in sequence. Then I just put the part that repeats. If x is even, L.append x. Then at the end here, I return the list. There. So if I do all evens, then the same range, this will give me all of the even numbers inside a list. Okay? So same idea. If you notice here, you could also do this with a comprehension. This is the same thing as x for x in the range 1 to 20 if x is even. So same thing. It's arguably a bit shorter or simpler, but the point is, it's important to know how to also do it with a for loop like this. Okay? Alright, what else? So remember that this pattern, where we have an if at the end of the comprehension, we call this filtering. Aside from filtering, we also had mapping, or doing something to each element of the sequence. So let's look at an example of mapping. So for mapping, I want to collect all of the even numbers again, but I want to square those numbers as well. So let's do that. Define squares of evens. So same thing, I start with an empty list. I start with the first element of the sequence. If that element is even, I'm going to append that element squared. So x squared instead of just x. So I append x squared, then I move on to the next element. if x is even, L dot append x squared, and so on. So if I want to roll this into a loop, what I would do is I start with the empty list, then I iterate over the sequence for x in sequence. If x is even, this is the part that repeats, I'm going to append x squared. And I should return the list at the end. Okay? So if I now do squares of evens, then range 1 to 20, I get the squares of each of the even numbers here. So same idea as the previous ones. Start with the unrolled version, then roll that back up into a for loop like this. Okay? Again, you can also do this with a comprehension. It's as simple as x squared for x in this range if x is even. Same thing. But yeah, it's also important to figure out how to do it with a for loop like this. Okay. So aside from manually putting a range or using the same sequence, you could also do, instead of sequence, you could reuse the code from a while ago. So events, all events. This gives us all of the even numbers, so calling this would give us the same thing. So yeah, that's just one minor change you can do. Okay, what if we want to put our output into several different things? So for example, I want to separate the even numbers and the odd numbers and odds of a sequence. For this, I want to build up two sequences in the end, or two lists in the end. One for the odds, one for the evens, one for the odds. So what I can do is I start with two lists, equals two empty lists. Then I again iterate over each element of the sequence. If x is even, I append it to the evens list. Otherwise, I append it to the odds list. I do the same thing for the second element. If it's even, I append it to the evens list. Otherwise, I append it to the odds list. And this just keeps going on and on until I return evens then odds. So if I want to roll all of that back up, define evens and odds. If we look at yung unrolled version, I'm iterating over the same sequence using the variable x. So let me start with the stuff I want to return at the end. Evens, odds is two empty lists. Then for x in sequence, if x is even, I append that to the end of evens. Otherwise, I append that to the end of odds. Then in the end, I just return evens, then odds. There. So these parts remain the same from the unrolled version. I just rolled back up everything that's in the middle over here. This part over here is what appears in the inside the for loop. If I do evens and odds now, and odds range 1 to 20, I now have the even numbers and the odd numbers separated. Okay? So that's how I can use a for loop like this. Okay? So this is what we just did. You can also write this if you don't want to write this part again. It's also possible to put the list that you want to append to inside a ternary operator, like this. And you can also do it like this. Have a tuple of lists, then you decide the index based on each number. So this is another solution. Okay? Alright, I'll stop here first. Any questions so far for loops? No questions? This should be relatively easier naman. compared to the stuff in the first arc. So yeah, once you get through Hope 1, it should be a bit more tolerable, hopefully. But yeah, good luck in Hope 1 this Wednesday. We'll release yung seating arrangement tonight siguro. You'll either be in TL2 or TL3. But yeah, if you have no more questions, that's going to be it for today. And see you next week.